Antiderivatives involving inverse circular functions. So it's important that we realise what the integral is. So you can see here, there's the integrals there. This one, first one's for sine, it's got a positive one at the top, and then it's a negative inside the square root. And then the cos is a negative there, and the tan doesn't have a square root at all, and it's a positive there. So if we get them all in this form, then it's easier to actually work out the integral. Example 7 says find an antiderivative for each of the following. Question 1, so I'm just going to write part A as the integral of 1 divided by the square root. Now instead of 9, I'm going to write it as 3 squared minus x squared dx. Now if you remember, this is the actual sign, so this is inverse sine of x divided by 3 plus c. Part B. Now again, I'll write this as the integral, but this one has a 4 in front of this x squared. We really want a 1. So I'm going to take out the 4 from here, which means I have a 4 here as well, divided by, and the square root of 4 is 2. So I'm going to write it as a half, the integral of 1 divided by the square root, and instead of 9 over 4, I'm going to put 3 on 2, all squared, minus x squared, because remember we took out the 4. And I better put my dx. So this becomes a half inverse sine of x divided by 3 on 2. And I have my plus c, which is just a half inverse sine of 2x over 3 plus c. I thought I'd better show you everything for this one here. Part C again, this is the tan, but of course I've got the 4 here, so I'm going to take out the 4. So I've got 1 divided by 4, 9 on 4 plus x squared dx. Now I'll write the 9 as 4 is 3 on 2. The 4 I'll take out, so there's the quarter there. So I'll have 1 divided by 3 on 2 squared plus x squared. Now really, this one, I have to have it as a 3 on 2. So the only one I'm going to have it as a 3 on 2 is if I change it to 2/3 times 3, 2. And now I can pull this 2/3 out. So pulling that out, I'm going to get a quarter times my 2/3, the integral of 3 on 2, 3 on 2 squared plus x squared, because that's what I need for tan. This simplifies. 1, 2 becomes a sixth, so I've got a sixth. Now I've got tan to the inverse of x divided by 3 on 2, which is just going to be 2x on 3 plus c. Example 8, evaluate each of the following definite integrals. So now we know the integral between 0 and 1 of this one here. Again, let me just rewrite this. So this becomes the integral between 0 and 1 of 1 divided by the square root of 2 squared minus x squared dx. So that is inverse sine of x divided by 2. And we'll have to work that out between 0 and 1. So this becomes inverse sine of a half minus inverse sine of 0, which is just pi on 6. For B, I have the same thing. The integral from 0 to 2 of 1 divided by 2 squared plus x squared dx, which means I have inverse tan of x divided by 2, and this is between 0 and 2, which gives me tan to the negative 1 of 1 minus inverse tan of 0, which is going to give me pi on 8. And C, this one here, I'll have to rejig this one. This is the integral between 0 and 1 of 3 divided by 3 on 2 all squared minus x squared dx, and I have the square root of 4 out here, which becomes 2. So I'm going to pull out the 3 on 2, and I've got the integral from 0 to 1 of the square root of 3 on 2 squared minus x squared. I left that on purpose. Okay, at the moment I'll just put that in there just in case this was a tan, but it's not, it's a sine, so I don't need to do that. So then I'll get 3 on 2 And I've got inverse sine of 2x over 3 between 0 and 1. So then I've got 3 on 2 inverse sine of 2/3, because sine of 0 ends up being inverse sine of 0 is 0, so don't even bother doing that one. So this is approximately 1.095 when you work it out.